Hello everyone, this is Aishwarya from Sri Venkateshwara College of Engineering. Today in this video you will be knowing about data structures and applications of static hashing. Hashing is a fundamental data structure that efficiently stores and retrieves data in a way that allows for quick access. It involves mapping data to a specific index in a hash table using a hash function, enabling fast retrieval of information based on its keys. This method is commonly used in databases, caching systems, and various programming applications to optimize search and retrieval operations. Let us see what is bucket overflow. If a bucket becomes full, records are stored in an overflow bucket with infinite capacity located at the end of the table. All buckets share the same overflow bucket. A well-designed implementation uses a hash function that evenly distributes hash records among the buckets to minimize the use of the overflow bucket. Now let us see what is the advantage of hash function. Using hash functions for authentication offers several advantages such as speed and efficiency in processing large amounts of data, as well as one-way protection from attackers. Hash functions are also collision resistant, making it unlikely that two different inputs will produce the same hash. It offers a predictable performance as the hash function and storage structure do not change during operation. Static hashing provides fast retrieval of data as the hash function directly maps keys to their respective storage locations. Let us see few disadvantages of static hashing. Hash tables offers efficient data storage and retrieval, but they come with some drawbacks. These include collision resolution, variable performance, space overhead, lack of ordered data, and dependency on a quality hash table function. They are not ideal for range queries, and resizing can introduce overhead. Static hashing may not be suitable for dynamic datasets that require frequent insertion or deletions. Handling bucket overflows can impact the overall performance of static hashing, especially in some scenarios with high collision rates. Now let us see how the static hashing will be implemented. Hashing is implemented in two steps. An element is converted into an integer by using a hash function. This element can be used as an index to store the original element, which falls into the hash table. The element is stored in the hash table where it can be quickly retrieved using hashed key. To implement static hashing, the dataset is divided into fixed size buckets based on the hash function. During retrieval, the hash function is used to determine the bucket containing the desired data. Each bucket is assigned a unique identifier and data is stored in the respective bucket based on the hash value of the key. Hash functions in static hashing. A hash function is a mathematical function that converts any digital data into an output string with a fixed number of characters. Hashing is a one-way act of converting the data, called a message, into the output, called the hash. Common hash functions used in static hashing include division hashing, multiplication hashing, and universal hashing. A good hash function should generate unique values for different keys while minimizing collisions. The choice of hash functions is crucial in static hashing as it directly impacts the distribution of keys across buckets. Now let us see the collision resolution techniques. When one or more hash values complete with a single hash table slot, collisions occur. To resolve this, the next available empty slot is assigned to the current hash value. The most common methods are open addressing, chaining, probabilistic hashing, perfect hashing, and scholastic hashing technique. Each collision resolution technique has its advantages and disadvantages influencing the overall performance of static hashing. What is linear probing and static hashing? A hash collision occurs when the hash function maps a key into a cell that is already occupied by a different key. Linear probing is a strategy for resolving collisions by placing the new key into the closest following empty cell. When a collision occurs, the key is inserted into the next available slot in the bucket, ensuring data can be retrieved without chaining. Linear probing is a simple to implement but can lead to clustering and degraded performance in case of frequent collisions. Now let us see what is quadratic probing. Quadratic probing is an open addressing scheme in computer programming for resolving hash collisions in hash tables. Quadratic probing operates by taking the original hash index and adding successive values of an arbitrary quadratic polynomial until an open slot is found. By incrementing the probing sequence quadratically, quadratic probing reduces clustering and improves performance compared to linear probing. However, quadratic probing may still suffer from clustering under specific conditions. Use cases of static hashing. Static hashing is commonly used in databases for indexing and fast retrieval of data records. It is also employed in file systems for organizing and accessing files efficiently based on their keys. In network applications, static hashing can be used for load balancing and routing packets based on specific criteria. Let us see the difference between static hashing and dynamic hashing. Static hashing, a fixed number of buckets is allocated to a file to store the records. Dynamic hashing, it allows the number of buckets to vary dynamically. Static hashing uses a fixed hash function to partition the set of all possible search key values into subsets and then maps each subset to a bucket. Dynamic hashing uses a second stage of mapping to determine the bucket associated with some search key. Static hashing performance degrades due to the bucket overflow. Dynamic hashing performance does not degrade as the file grows. Static hashing, it uses a dynamically change function that allows the address space to grow and shrink with varied databases files. Dynamic hashing, the index entries are randomized in a way that the number of index entries in each bucket is roughly the same. Static hashing is a powerful technique for efficient data storage and retrieval in various applications. By leveraging well-designed hash functions and collision resolution techniques, static hashing can offer predictable performance and fast access to data. Understanding the principles and best practices of static hashing is essential for optimizing its performance in real-world scenarios. This is all about static hashing.